This is the most disliked place on Earth. It is a desert almost devoid of human life, yet here, a remarkable piece of engineering is under construction, nothing short of a marvel. In the middle of Chile's Atacama Desert, atop a mountain 10,000 feet above sea level, the world's largest telescope is being built. Standing 40 meters taller than the Leaning Tower of Pisa, this telescope, once completed, will be capable of observing distant planets in our universe 5,200 times closer than the naked eye. Moreover, its images will be 15 times sharper than those captured by the Hubble Space Telescope. Building the world's largest telescope in the driest place on Earth is nothing short of a miracle. The Atacama Desert, second only to Antarctica, is the driest place on Earth, with some areas that have never received a single drop of rain in recorded history. This telescope will have the capability to peer back in time to observe the first galaxies, stars, and planets in the universe, potentially aiding scientists in discovering planets similar to Earth. The construction team has encountered significant challenges, especially in building a football field-sized dome at the high altitudes of the Atacama Desert. Let's explore the obstacles they faced and the innovative solutions they implemented to overcome them. The Atacama Desert, stretching 1,000 kilometers along South America's Pacific coast, is recognized as the driest place on Earth after Antarctica. Its natural beauty is truly unparalleled, featuring towering volcanoes, the salt-covered Death Valley, vast desert plains, and a one-of-a-kind fog phenomenon. However, one crucial element is missing here: water. The unique landscape of the Atacama Desert means it receives virtually no rainfall, with some areas having never experienced a single drop of rain in recorded history. Because of these unique characteristics, the Atacama Desert closely resembles the surface of an alien planet. Perhaps this is why the European Space Agency selected it as a testing ground for its Mars rovers. Situated 1,300 kilometers from Chile's capital, Santiago, and 130 kilometers from the nearest city, this mountain rises 10,000 feet above sea level. Here, an extraordinary project is taking shape, providing humanity with an unprecedented opportunity to explore and view other worlds in space. The European Southern Observatory, ESO, is building a massive telescope here, aptly named the Extremely Large Telescope, ELT. Although construction is still underway, it's clear why this telescope deserves its name. It will boast a giant mirror, 39 meters in diameter, 4 times larger than the largest telescope currently in existence. This colossal mirror will be capable of capturing 100 million times more light than the human eye. To protect the telescope from dust, it will be housed in a massive steel dome weighing approximately 6,000 tons, the equivalent of 2,400 pickup trucks. The dome will feature 2 large doors that stay closed during the day. It is so tall that the Statue of Liberty could fit comfortably inside, with enough space to accommodate an entire football field beneath it. Beneath the dome, a high-tech platform will enable the telescope to rotate 360 degrees, allowing seamless observation of any part of the night sky. Building this project in such a remote area, with no nearby cities, roads, electricity, or water, was an enormous challenge. The construction team faced numerous obstacles just to begin this complex endeavor. Initially, several locations in Europe were considered, but the team ultimately chose South America. According to the project head, the primary reasons for selecting this location were its distance from city lights, which eliminates light pollution, and its exceptionally clear skies, essential for precise astronomical observations. The Atacama Desert, one of the driest regions on Earth, has clouds on only 45 days of the year, making it an ideal location for observing distant galaxies. In 2010, the team tested several potential sites before selecting this one. The chosen mountain, Cerro Armazones, stands 3,000 meters high but presented a significant challenge. Unlike other mountains, it had a steep, jagged peak, making construction impossible without first leveling the summit. In 2014, the construction team used explosives to flatten the mountaintop. They drilled holes and deployed remote-controlled explosives to blast away the top 100 meters, removing 4.7 million cubic meters of earth. To put this in perspective, that amount of material could fill 1,911 Olympic-sized swimming pools. After clearing the debris, The team created a flat surface and a pathway to access the summit. But that was only the beginning. After leveling the peak, a new challenge arose: sinkholes. The explosives had weakened the mountain's core, causing cracks in the rock and areas of the ground to sink. Engineers tackled this problem by using artificial vibrations to stabilize the ground, which allowed them to fill the sinkholes and re-level the surface. This painstaking process took an additional 5 years. Once the foundation was secure, the next obstacle was the seismic activity in this part of the desert. Earthquakes are common, posing a significant threat to the telescope's delicate and expensive components. To address this, engineers separated the foundation of the massive steel dome from the telescope itself by installing hydraulic shock absorbers. These absorbers protect the telescope and its giant mirror by preventing earthquake vibrations from reaching the structure. By 2023, the foundation work was completed, and construction of the giant steel dome began. The steel components of the dome were fabricated at a base camp and then transported to the mountaintop using remote-controlled trucks. Cranes were employed to assemble the massive steel structure, piece by piece, like a giant Lego model. The road network to the site had already been partially established due to the presence of another telescope, the Very Large Telescope (VLT), located 20 kilometers away. This road network was extended all the way to the summit of Cerro Armazon. What makes this telescope so extraordinary is its 39-meter mirror, which will be constructed from 800 smaller pieces. Once complete, it will capture light from distant galaxies. The light will then pass through a series of secondary mirrors, M2, M3, and M4, each one enhancing the sharpness of the image further. To counteract atmospheric distortion, the telescope employs powerful lasers that create artificial stars in the sky. These artificial stars serve as reference points to correct the distortions caused by the atmosphere. This technique, known as adaptive optics, enables the telescope to produce crystal-clear images. After the image is corrected, the light is directed to M5 for final processing. The ELT will also have the unique ability to take direct photographs of exoplanets outside our solar system, especially those with potential signs of life. By analyzing the atmospheres of these planets, scientists will be able to detect the presence of water, carbon dioxide, oxygen, or even pollution, indicators similar to those found on Earth. Thanks to the size of the ELT's mirror, it will be able to capture an enormous amount of light, enabling it to observe the early universe. This is similar to how we can see the past of the sun every time it rises, because sunlight takes 8 minutes to reach Earth. The Hubble Space Telescope can look 13.4 billion years into the past, but the ELT will extend that reach by 100 million years. This means it will be able to capture scenes from the universe just 30 million years after the Big Bang, which occurred around 13.8 billion years ago. Although the ELT is enormous, it is the largest optical telescope, not the largest overall. Radio telescopes, such as the one in Golden Eye, use large dishes to capture radio waves and create images of the past. In contrast, the ELT will allow us to directly observe distant objects in space, making it the world's largest optical telescope. If you enjoyed this video, please don't forget to like, share, and subscribe. Your support means a lot and helps us bring you more exciting content. Thank you.